Hey guys, this is the AC Service Tech, and today what we're looking at is a package unit that I diagnosed with a bad thermostatic expansion valve. So I'm just going to show you what the pressure readings look like and the temperature. So we're going to look at superheat, and we'll discuss why the TXV is bad. So I'm just going to go ahead and give you a shot just what this package unit looks like here. I'm going to hook my gauges up to here. You have your low side right here connected into your suction line. That goes right into the compressor. So that's this gauge right here. We're just going to put test ports on there. Quick connect test gauges. And here is your high side. Inside this unit has a TXV as a metering device. So we would check subcooling on this unit to make sure the charge is correct. But in this case, what I want to do is I want to check the superheat to see if the TXV is actually working properly, and we actually have a high superheat, and that's what the problem is. The vapor side is down below freezing, and it's just too low. The evaporator coil ends up freezing, and the problem with this is you want to see if it has low superheat, meaning that you have an air blockage, or you have high superheat, meaning that the charge is low or there's a restriction in the liquid line. That could be the filter dryer, like that filter dryer right there, or it could be the screen, or it could be the thermostatic expansion valve, or even the distributor tubes. So I'm going to go ahead and check the superheat. I'm going to put this temperature probe in through this way because I'm going to put this door back on. This is part of the condensing portion area. So I need to have this door on in order for the air to be pulled across the condenser coil. So the unit just turned on, and the pressure sometimes will be low on systems and then will gradually rise to the pressure it needs to run at. So the pressure, as you can see right here, is right about 42 psig on the outer ring, though the camera is on an angle so it might look a little lower. And if you follow that into the green temperature, so that's R22, this system is R22, it's actually about 18 degrees in the middle of the evaporator coil. So the pressure ring tells you the pressure on the low side of the system. The green saturated temperature tells you the temperature in the middle of the indoor coil during cooling. Okay, so if you compare 18 degrees with 86 degrees actually on the vapor line, you can tell that you have a dramatic amount of superheat, a lot of superheat. I actually put insulation around the temperature probe because it's inside where the air is being sucked across the condenser coil and blown out the top, because you have little quarter-inch lines coming over here to each of these ports. So this still may be a little high, but that temperature is very higher than this. So that either means that you need to add refrigerant, or that you have a liquid line restriction if you have high superheat. If you have a liquid line restriction, that means that it's not allowing enough refrigerant to go into the evaporator coil to absorb all the heat getting put across the evaporator coil from the air. So 87 degrees and about 18 degrees, you have about 70 degrees of superheat. It's a lot of superheat. The subcooling is actually correct. In fact, actually, it's a little higher than what it needs to be. Although when you have these package units, sometimes the ports are not quite in the right spot to get your readings at. But the subcooling is actually correct. It's actually a little higher than what it needs to be. So that means that you do not add more refrigerant into the system, because it does have a thermostatic expansion valve as the metering device in cooling mode. So you don't want to add more refrigerant. A lot of times when you have high superheat, that means, yeah, add refrigerant. But in this case, you can tell that there's a restriction in the liquid line not allowing enough refrigerant through. So now I'm going to take you into the inside of this unit and just show you what the TXV looks like. So maybe you can see right there the TXV is rusted. See this? It's all rusted, and the top is actually rusted all right here. Okay, so I think that this head has lost some of its refrigerant charge. That's why it's not able to apply pressure downwards in order to open up this refrigerant in order to come through. So I want you to remember that low superheat means low airflow, and high superheat means either a low refrigerant charge or some type of liquid line restriction that's not allowing the refrigerant from in the system to go into the evaporator coil. The way that you determine whether a system is a liquid line restriction or a low refrigerant charge is with the subcooling. If you have high subcooling or normal subcooling, but your low pressure side is just too low and the saturated temperature is just too low on the low side gauge, then that means that you have a liquid line restriction. I also took this cork tape off of the TXV bulb, took the bulb off of the suction line, and I put it in a cup of hot water, and I was able to rise the pressure up on the suction line. So I knew that the problem had to be with that TXV, and this bulb reading is a confirmation. What this bulb reading told me was that there still is pressure in here, but not enough to open up the thermostatic expansion valve enough to have a proper superheat reading. Remember that the TXV's job is to maintain the correct amount of superheat across the evaporator coil. So you know, I've added the links to tools used in this video down in the description below, such as the quick connect test gauges and the multimeter with the temp sensor. Hope you enjoyed yourself, and we'll see you next time at AC Service Tech channel.